All right, hey gang. Man, I'll tell you what, that snow came in about perfect for you guys today. Not much on the ground when I first came to school this morning. It was slick, and I just knew it wasn't going to get much better. And boy, oh boy, about what was it, about 8:30, it was just coming down. So, anyways, hey, here we are again. So here's what I'm going to do for you. Between now and when I post this, I am actually going to post the answers to your Chapter 6 review. Okay, that'll be part of the Blizzard Bag post. Please look that over. Come tomorrow with questions. I'm almost positive we're going to have school tomorrow, so come tomorrow with questions, okay? A lot of that is dependent upon wind. I hear we're supposed to get some wind tonight, so we'll see what happens, okay? So again, Chapter 6 review. Have that looked over. Make sure you know what you're doing with that. If there's problems that you're not understanding, let's talk about that tomorrow in class, okay? The second thing I'm also going to show you is this. Your homework from last night. I am going to be posting, as you can kind of see here, out the side of your paper there. Let's see. I'm going to be posting these answers here on Schoology. So what was left over, numbers 2 and 4 from last night, as well as the problems you can kind of see here from page 498. I'll be posting those answers. And then I've got the lesson for you today. So I'll talk more about the lesson here in a second. But what I would like to look at real quickly with you guys is one of the problems from last night's homework, number 37, okay? It says a coronary artery, give me 1 second here just to make sure, yeah, we're good. Okay, a coronary artery may be dilated with a balloon catheter as shown. The cross-section of the middle of the balloon is a circle, okay? So as you look there, this is kind of a personal story problem because my dad about 15 years ago had a heart attack. And when they had a heart attack, I was able to see him just before he went in. Actually, I can still remember it like it was yesterday. Mr. Gherkin and Mrs. Frankert came down to my room, and they said it was in the fall, and they said, you need to go to the hospital. Your dad's in the hospital. I had no idea what was going on, and I was thinking the worst. I was thinking that he had had a farming accident. I was thinking that he had lost a limb. I had no idea. And what happened was he was out combining, and he thought he was having a heart attack. And he went over to the neighbor's pond, flushed his face, called my mom, and said, I think I'm having a heart attack. He didn't actually go to the hospital right away or call the hospital, which I have no idea why, especially knowing that his father had died of a heart attack while he was digging some tile in the fields. Okay, so my grandpa. So anyways, when I got to see him at the hospital, I felt confident that the doctors were going to take care of him, but at the same time, I don't think I should have been that confident. And not that I don't trust them, but sometimes, I mean, it's a heart attack. It was serious. The artery that he had the heart attack in was called the widowmaker, okay? And it's the one that most people don't survive. Well, anyways, they went in and they did exactly what they were talking about right here. They put a catheter in, they found the blockage, they blew it up with the catheter, and then they inserted what's called a stent, which is like a wire mesh that kind of pushes that artery out and allows the blood to flow freely, okay? And the amount of pressure that the cardiologist was on while he performed this surgery on my dad, I can't imagine, because my dad's literally, he's dying on the table, and it was extremely painful. And my dad said it was, for my dad, one of those tough old guys, farmer, he is not one to talk about pain much. And he said it was a lot of pain. So something I never want to experience, okay, hopefully. But again, this is a personal situation. So as we take a look back at the problem here, as I go back to the page here, it says the surgeon inflates the balloon of the catheter in a patient's coronary artery, dilating the balloon from a diameter of 1.5 millimeters to 2 millimeters. Find the scale factor of the dilation, okay? So the scale factor is how many times bigger is it? Now, noticing it's getting bigger, or how many times smaller, could be either way. But how many times bigger is it? So what I did was I took the larger number, this 2 millimeters, and put it over the smaller number, 1.5. And you divide that out and you get 1.3 repeating. Now what that shows us there is this. that the dilation that took place, how much bigger it was 1 1/3 or 1.3 repeating times bigger. Okay, that's the scale factor. Remember, yesterday we talked about if it's a larger number than 1, it's getting bigger. If it's a smaller number than 1, then it's getting smaller. Okay, so just a couple of things to think about there. Find the cross-sectional area of the balloon before and after the dilation. Now, if you look here, the cross-section, if I was to cut this thing in half right here, or cut this one in half right here, and open them up, what shape would you see? And you would see a circle. That's why it's mentioned here. The cross-section of the middle of the balloon is a circle, okay? And so what we end up seeing here, I didn't actually do that, sorry. It should have been right like this, okay? So the cross-section, if I cut it in half right here, or if I cut it in half right here, you end up opening it up, you have a balloon. So sorry about that. Now, if you take a look here at my answer key that I am also going to be posting in Schoology. This is the drawing that I did before the cross-section, the circle. Remember, it said the diameter was 1.5, and this is the drawing I have for after. The diameter here is 2 millimeters, okay? And so the area of a circle, the area of the cross-sectional is going to be pi r squared. It's the area of a circle. The radius here would be half of 1.5, and so we square that and multiply it by, I should have had squared there. There we go. Multiply that by pi, you get 1.77 millimeters approximately, millimeters squared. Over here, if I square 1 and multiply it by pi, you get 3.14 square millimeters. Okay, so as you look at that, while we're only increasing the diameter by 0.5 millimeters, we're increasing the area. It's almost double the area. Okay. So just something to think about there. Okay, now let's on to today's lesson. Let's talk about today's lesson here. And the first thing that I want to get into for today is 2 things that you're going to have to memorize about all similar figures, okay? All similar figures have these 2 characteristics, okay? If I look down here and just make some observations, the one characteristic that I see, if these 2 figures are similar, is that their corresponding angles are congruent. So I'd like you to write that down. For all similar figures, the corresponding angles are congruent. Okay? Which is why the figures will look similar, because the angles remain the same. Okay? But the sides aren't the same. So if I take the smallest side, well, actually, let's take the side between the 1 and 2 congruency marks here. I'll match that with the 1 and 2 congruency marks over here. So if I take the 15 and match that to the 20, doesn't matter if I had the 20 over the 15 or the 15 over 20, it doesn't matter. But if I'm going from this one to this one, it has to be that for the rest of them as well. Between 2 and 3 congruency marks, I have 12 and 16. And between 18 and 24, 1 and 3, you have 18 and 24. Okay. Another way to look at this would be to match up the smallest with the smallest. The smallest with the smallest. Okay. The medium with the medium, and the largest with the largest. Okay. Now, what you're going to notice about each one of these ratios, these fractions, they are all equal. If I divide this one by 5, I get, dividing 15 by 5 and 20 by 5, I get 3/4. Dividing each of these numbers by 4, I get 3/4. Dividing each of these numbers by 6, I get 3/4. Okay? So what is it that I want you to know about the sides? It's that the corresponding sides are proportional. Now, what does proportional mean? You could say this in several different ways. You could say that they grow at the same rate. Really what proportional means is that a proportion is equal ratios. So I'll put down here equal ratios. Okay? So they grow at the same rate, meaning the rate of change, the fraction, okay, the slope, as we've talked about in the past, okay, or that they have equal ratios. So now, beyond the two characteristics, there's some terms that we have to know down here, okay? The first one is called the similarity statement, okay? Now, we've talked about congruency statements in the past. This is very similar to that. The similarity statement, if I were to go ahead and mark down triangle ABC, ABC corresponds with FED, looking at the congruency marks there, FED. Now, if I wanted to say that these were similar, if they were congruent, you'd put the congruency symbol between them. But if I want to say that they are similar, that little squiggle right there, that is the similar sign, okay? So what does this mean? It means is similar to, okay? So you've got that similarity statement. Now the similarity ratio, okay, actually I'm gonna cross this off. I'm gonna put scale factor down here. The similarity ratio, if we're going from small to big, meaning we're increasing, remember each of these reduced down to 3 and each of these reduced down to 4 if I did the fraction over here, okay? So if I want to go from small to big, meaning I'm increasing in size, my similarity ratio is going to be 4 to 3, okay? If I was going from big to small, it would be 3 to 4, okay? This one is greater than 1. This one is less than 1. Each of these ratios could be written as a fraction too. So 3/4, meaning we're getting smaller, or 4/3, we're getting bigger, okay? Now the question I oftentimes have is, which one is it? Which one's going to be the right answer? And the answer to that is, if I go ahead and tell you, hey, tell me the similarity ratio from small to big, as it increases in size, I'm going to have you give me 4/3. If I say as it decreases in size, I'm going to have you tell me 3/4, okay? If I don't give you either one of those, then I'll have to accept whichever one you come up with, okay? So just keep that in mind. The scale factor, then, if we're getting bigger, okay, I'm actually going to divide these out. 4/3 is going to be 1.3 repeating, okay? That's the scale factor, how many times bigger it is. If it's getting smaller in size, you can put down 0.75, okay? How much smaller is it? Well, it's 3/4 the size of the original one, okay? So again, you could actually write the scale factor out as a fraction if you wanted to. I'd be okay with that. All right, now, as far as this next part is concerned, okay, it says that we have two quadrilaterals and they're similar to each other, and we have to complete the following statements. We did this back when we were doing congruent figures, so if you caught on then, this should be pretty simple. Angle M is going to have to be congruent to which angle? Now remember, the corresponding angles are congruent. So the angle that corresponds to M is going to be I right there. They're in that second position. So I'm going to put angle I. Okay. Angle K here corresponds to O here. So I'm going to say angle O. Those corresponding angles are congruent. Now down below where we have numbers 2 and 4, these are talking about the sides because they're in the same ratio to each other. So if I look at this, IJ is to MN, they're in the same spot on both those, as HK, now it's first and fourth positions, HK is to, and you should have LO, so this should be LO in the same position there, okay? So I don't need the picture as long as I have that similarity statement. MN, if I look, MN is to IJ, as blank is to JK. Well, JK is in third and fourth position, so NO is going to be my numerator there, okay? Now, I'm going to have you guys go ahead and finish up 5 and 6. This will be part of your homework for tonight, the ones we don't finish, and then I got a couple problems from page 506 that I want you to work on. The next part says, list all pairs of congruent angles and write a proportion that relates the corresponding sides for each pair of similar polygons, okay? I'm not even going to look at the picture here. I'm not going to worry about that. I'm going to look at this right here, okay? So let's talk angles first. So the angles that would have to be congruent would be angle D and its corresponding angle, angle G. Okay? Angle E is going to have to be congruent to angle H. And angle F is going to have to be congruent to angle J. Okay? As far as the sides, how they are going to relate, remember they are proportional. I'm going to do DE, those first two. Actually, I'm not going to put the line above. I'll just put DE. Their first two positions, GH. EF is going to be to HJ. And DF is going to be to GJ. And they are all proportional, which means the ratios are all equal. Okay? So hopefully that's making sense to you as I'm just using that statement. I'm not even worried about that picture right there to set up my sides and my angles there. Okay? All right, now, going to look at a couple of these problems here. The next section talks about this. Are the polygons similar? So what we're really asking here is, are the corresponding angles congruent? Are the corresponding sides proportional? If they are, write a similarity statement and give a similarity ratio. If they are not similar, explain. Answers are below the following problems, okay? I'm not sure why I wrote that part because I didn't actually write the answers. So when I look at number one, I'm looking at the angles, and all three angles, the corresponding angles are congruent. So I'm going to put down, I'm not going to actually put down anything there for that. Let's talk about side lengths now. Now, between the 1 and 2 congruency marks, I'm going to say that we are going 10 to 5. We are going 1 to 3. Actually, you know what? I'm going to read this as if we're going from left to right. And if we are going from bigger to smaller, we're getting smaller here. I'm going to put 5 to 10 because I'm getting smaller. I have a number less than 1. The next one, 1 and 3, would be 6 and 12. And then you would have 7 and 14. Now, if I reduce each of these down, 1 to 2, 1 to 2, 1 to 2, these are all equal ratios, okay? So I'm going to say that my similarity statement is something like this. ABC is similar to triangle XYZ. If you notice the angles there, I'm just following the angles. And then I'm going to put down a similarity ratio. And I'm going to say something like this. It's a similarity ratio of 1 to 2. Meaning as we go from left to right, we're getting smaller there. Okay? All right. The next one, what I know in number 2 is that we have isosceles triangles. And if the vertex angle is congruent, then to these two vertex angles, then the base angles here and here would have to be the same measure as well. Okay? Now I have to see if the sides are proportional. Now we are getting smaller again, going from left to right. So I'm going to put 3 is to 5. And then I'm going to put down 4 is to 20 over 3. Okay? Now if I want to see if those are equal, I think one of the easiest things to do would be to use your calculator. And if I were to do 3 divided by 5, I get 0.6. Okay? 4 divided by, now look at what I'm doing here. I'm putting a parenthesis here. We get 0.6 as well. Okay? So these ratios are equal. So I'm going to say something like this. Triangle RST is similar to triangle QMN. You could have put down QNM because isosceles can go either way. It's equal on both sides, so I'm okay with that. For the scale factor, or not scale factor, the similarity ratio, is going to be reducing this down 3/5, 3 to 5. Okay, It's actually 60% of the size, 0.6, so 60% of the size of the original one, okay? For number 4, we can look at those and know, nope, they are not similar. And I'm going to put down just something like this, not similar, because the corresponding angles are not congruent. Okay? So hopefully that makes sense to you. You can tell just by looking at them that is not going to work out. Okay? All right, number 5. As I look at number 5, it says in the diagram the two figures are similar. Find x and y. Okay? Now, if you look here, AC and VW match up. So AC, I'm not going to say that they are congruent, even though I'm marking it like this, but I just want to show myself which CD matches up with WY, and then DF matches up with YZ, and that would mean that this side here would match up with that side there. I don't know how you want to do it. I don't think that's a good way, because I don't want you to be tricked into thinking that those sides are congruent, but I do want you to know that they match up to each other. So the reason why I did that is because as I look at WY and I look at CD, they match up with each other. And so I know that my ratio going from big to small is going to be 9 to 6. Okay? Now, if I want to figure out what x is going to be, I'm going to go from big to small and match up those two sides. It's going to be x is to 10. Okay? So if anything, that is key in this problem is to pay attention to the similarity statement. Don't just look over here, because I can see a lot of people saying that these two sides are similar and these two sides are proportional. Okay? Now, if you remember when you had problems like this, you cross multiply. 6 times x, 9 times 10, and then divide through by 6, and you get 15. Okay? Now, to solve for the y, I'm going to go back to my original ratio again. Okay? And then the y side corresponds with the 12. So I'm going to do 9 is to... excuse me. 9 is to 6. And I'm going to do 12 is to 3y minus 1. Okay? Now, when I cross multiply here, here's the tricky part, and I want everyone to do this. Make sure you put parentheses around that. I see students all the time that will multiply 9 times 3, but not multiply 9 times the negative 1. You have to distribute to both those, okay? 6 times 12 is 72. So if we do this, 27y minus 9 equals 72. If I add 9 to that, I get 81. And I believe 81 divided by 27 is 3, and it is, okay? So there's your x and y values right there, okay? I don't know if you could graph those in Desmos. I may try that after this problem is over, but you might be able to graph both of those and figure out what your x and y values would be. All right, so for the last one, it talks about two quadrilaterals, AB to PQ, okay, so we got the markings there, okay? And you know what? I don't know why they marked them congruent, because they're not congruent. You've got 20 and 25. So just be aware of that. Okay. Find the scale factor and the perimeter of each polygon. Okay. So if I was to do this, the scale factor for these two figures, since they are similar, I'm going to match up AB with PQ. Okay, now we are getting bigger, and we're going from left to right, we're getting bigger. So I am going to switch that, since I kind of started that rule up above. If it doesn't say, I'm going to go from left to right. So I'm going to put 25 is to 20, okay? Now if I reduce that down, dividing both those by 5, you get 5 to 4, okay? So the scale factor, okay, I could just, actually I could have just divided those out. You could put 5 to 4 as my scale factor, or let's see here, 1.25. Okay, so this shape was a quarter size bigger than this one right here, so 1.25 times bigger. Okay. If I wanted to find the perimeter, I'd have to figure out what this length would be right here. Okay. In order to do that, I'm going to set up a proportion like this. 20 is to 25, as 14 is to x. Okay. Now, to make life easier on myself, I could reduce these down and make it 5 to 4. You don't have to, but you can. And then if you cross multiply, you get 5x. And 4 times 14, 40, 56. And if you divide by 5, you get 11 and 1/5, or 11.2. Okay? So, oh, I just realized something. I did something incorrect. No? Did I? Yes, I did. I did something incorrect. Let me go back here and fix this. Sorry about that. When I reduced it down to 5 to 4, it should have been 4 to 5. We need to go switch that. Okay. So let's go back here. Again, I apologize about that. 4x, and then 5 times 14 would be 50, 70. Okay. And then from there, dividing by 4, 4 goes into 70. 4 goes into 7 once. 4 goes into 37 times. 20.5. Let me just double check that there. 70 divided by 4. 17.5, yep. Okay. So the perimeter, what's it say we're doing? The perimeter of each polygon. The perimeter of the one polygon is going to be 40 plus 28, so 68 units. The perimeter of the bigger polygon is going to be, actually since we're getting bigger, I'll switch this for a second. You'll see why. Okay, 50 plus 35, so 85 units. Okay. Now, something I want you to see when I do this. If I divide this out, 85 divided by 68. This is called the perimeter ratio. Okay. Look at what we have here. Look at what we had for the scale factor. The perimeter ratio and the scale factor, or the perimeter ratio and the similarity ratio, will always be the same. Okay. So in this case, the perimeter is also 1.25 times bigger for the bigger figure than the smaller figure. Okay. All right. So that was a lot. I apologize for the length of time, but we covered a lot of good stuff there. You have number 3 right here. I want you to finish that up for me. I want you to finish up 5 and 6. And then you have a couple of practice problems right there from page 506 that I'd like you to work on as well. So thank you for listening, folks. I hope you have a great day off. We'll talk to you hopefully tomorrow. See you guys.